Hello, everyone. So today is another session in the MICCAI RISE Journal Club. For today's session, Philippe Gottfrois decided to present his paper that was also presented in an oral presentation in MICCAI 2024, Passion for Dermatology, Bridging the Diversity Gap with Pigmented Skin Images from Sub-Saharan Africa. So Philippe is a PhD student in the University of Basel in combination with the University Hospital of Basel under the supervision of Professor Alexander Navarini. And he is targeting bias privacy issues in the dermatological datasets in combination with the use of machine learning to try to improve the representation of these datasets that are so biased that we have in our medical field. So I hope that we have a nice session, and Philippe, hello to you. Thank you so much.
So hi everyone. As Alvaro said, I'm Philippe. I will quickly start with the conflict of interest. So I'm a PhD candidate of University of Basel and employed by University Hospital Basel. I have fast worked with some pharma company doing lectures and presentation, and the project I'm presenting is funded by Fondation Botna and the University Hospital Basel. And first, I would like to start with dermatology in Africa. About 87% of the children population suffers from skin disease in Sub-Saharan Africa. If you compare also the access to dermatologists between, let's say, Europe, where I'm currently living in Switzerland, and Sub-Saharan Africa, we have a striking difference in the possibility to see a dermatologist. In Europe, you would have about 1 to 11 dermatologists for 100 people, depending on the country. Typically, Switzerland has a lot of dermatologists per habitant, while if you look at Sub-Saharan Africa, usually the numbers are between 1 and 2 million people per dermatologist. Moreover, dermatologists are usually concentrated in big cities, meaning that rural access is almost impossible. And there is a high load of pediatric dermatology patients. About 35% of the patients are under 15 years of age. In the meantime, up to 80% of skin condition belongs to 3 families of skin condition: eczema, fungal, and to a lesser extent, scabies. Eczema is a chronic skin condition that is characterized by inflammation, redness, and itching of the skin. The key symptoms are some dry areas, scaling, redness, and sometimes swelling. The intense itching is also very present in most of the patient, and this condition can also lead to possible skin infection due to lesion made in the skin. There are multiple causes to eczema. First, it can be with some genetic predisposition, but more often it's linked to environmental factors such as allergens, irritants, and also sometimes immune system dysfunction. The treatment for this is widely available and fairly simple. It is the application of topical corticosteroids, moisturizer, antihistamines, and sometimes phototherapy for the most severe cases. And the prevalence is very high in children, but affects, in fact, all ages. Fungals, on the other hand, are infection caused by fungi that affects skin, nails, or even internal organs. Symptoms are also redness and itching of the skin, quite often discoloration, and for nails, thickening. Depending on the affliction, for example, if your lungs are affected, you can also have cough and fever. And as said, it's caused by fungi such as yeast. Typically, Candida or molds are also a source of fungal infection. And the lower your immune system, the higher the risk to get such an infestation. Treatment is also widely available based out of antifungal medication, and the prevalence is basically the entire population. Finally, scabies, or parasitic infestation, where microscopic mites burrow into the skin. It is highly contagious, and it's spread through direct skin-to-skin contact. Symptoms are intense itching, especially at night. That's where the mite's activity is the highest, and it's often accompanied by pimple-like rashes. And sometimes you can also see the burrows on the skin. And the itching is due to an allergic reaction of the mice, their eggs, and their waste. The causes is the female mite dig burrow into the skin to lay their eggs. Mites can survive about a month into the skin, and then new mites hatches, and then you have this kind of cycle that is extremely difficult to break unless correctly treated, treatment or permethrin or ivermectin usually. And once again, those are treatments that are accessible because they are quite often provided for free by several pharma companies. The prevalence is quite high. It's affected about 300 million people worldwide. However, this prevalence is not evenly spread. Typically, here in Switzerland, we have almost no case of scabies, where in Sub-Saharan Africa, that is fairly prevalent. And the idea of the patient project was based out of this assumption. So there is a lack of dermatologists in Sub-Saharan Africa. So we need to improve the access to the patient to a good skincare by enabling patient and medical officer to have a correct diagnosis of the condition, and then to directly suggest treatment strategies. The condition as I've presented have very simple treatment strategies, and as I said, treatments are available. What is also key for the project is to have a low threshold for the user, which means that we want to be able to use smartphones to take picture of the skin condition and explore an AI as a triage solution, because teledermatology enables you to link patient to dermatologists more easily, let's say for remote areas. But first, so you need, of course, an internet coverage. But more importantly, it doesn't increase the number of dermatologists. So we need a way to perform some triage to enable the dermatologists to focus on the more complex cases, and maybe have an AI solution that can focus on the easy to treat cases that are the more prevalent. This is a very simple schematic of how we are thinking to do this. First care provider or patient take picture using smartphone or camera, then they can access either through a messenger such as WhatsApp, website, or smartphone app to a teledermatology service. Then you have a triage, and either you have a feedback directly provided by the AI system, or the dermatologists are not taking charge because the case is more complex. The idea also is to test this solution with clinical study in order to assess the efficiency of the method. There are 3 phases to this study. Currently, we just finished stage A, which was the evaluation and comparison of teledermatology and dermatology. Study B will be comparison of teledermatology done by dermatologist and teledermatology done by machine learning model. And then we will have a phase C in the study, that is follow-up of the patient and to see the outcome of the method. Obviously, if with study A and study B, we have results that are positive. Now, for creating an AI-driven model, we need data and data sets. And the current landscape of dermatology, there are 2 types of data sets: dermoscopy images or clinical images. Dermoscopy images is the one you can see on the left. It's taken through a dermoscope. You have here a picture of what a dermoscope is, and it provides a very close-up image of the skin. This is actually the biggest source of images we currently have in dermatology that is publicly available. There are about 200,000 of these images now, thanks to a huge effort from the ISIC Society. But these images are mostly featuring skin lesion. So typically the presence or the absence of melanoma, nevi, seborrheic keratosis, lesions that are not very relevant in our case. Moreover, we want a system that is available for most of the population, so we can't rely on a tool that can be very expensive. So we want to use smartphone or camera images. And that's exactly what clinical images are. There are existing datasets also, but as you can see, the number are very different from dermoscopy images. And now you might wonder, why do we need to create a new dataset for the patient project? Because there are existing images. And the reason for that is very simple. Let's take to evaluate the amount of images with different skin pigmentation, the Fitzpatrick skin types. This is, of course, a scale that is not ideal. No scale is ideal, but it's widely used in dermatology, and it's the one that the dermatologists we work with in all the countries, we had this collaboration, that's the scale they were the most comfortable with. And if you see the graph on the top right side of the slide, this is the distribution of the skin types in the existing data sets. And you can clearly see that for Sub-Saharan Africa, where most of the skin types are of type 4, 5, and 6, there is a huge lack of data. And is it indeed important? Here below on the slide, you can see for a case of impetigo with different skin type, you have very, of course, different images. And we all know that machine learning models do not react well when presented with data that is completely out of the training set. And that is the big risk we have now if we only use existing datasets. So we need a new dataset. And for us, for our project, the dataset needs to fit 3 goals. First, it must target the pediatric population because it's the more affected. Second, we want to focus on common conditions, so we need to have 4 classes: eczema, fungal, scabies, and then other class. And we also want to detect the presence of impetigo. Why? I will talk about in the next slide. Then the third point is the Fitzpatrick skin types. We want to focus on type 3, 4, 5, and 6. Now, why to detect the presence of impetigo? As I said, the goal of the project is to be able to diagnose, but also to predict the right medication. And impetigo is a bacterial skin infection. It's caused by Staphylococcus, either aureus or pyogenes, and the symptoms are red sore, ooze, and develop honey color crusts, as you can have seen in the previous slides. Typically, it's located around the mouth, nose, or the face, but it can also be in all of the body, depending on how much you're affected. It's caused by bacterial infection, and the root cause most often is broken skin due to cut in the skin, scrapes, or eczema. And that's exactly why for us, because we're looking for eczema, we need to detect impetigo. Because if you remember, the treatment I talked about for eczema is usually corticosteroids. The corticosteroids, what they do, usually they reduce inflammation, and to do that, they have an impact on your immune system. So they decrease the effectiveness of your immune system. And eczema, because you have this dry scaling of the skin, creates broken skin. And so therefore, if you only provide eczema, the treatment for eczema for a patient that has impetigo, the bacterial infection will develop much quicker, and that can be a big issue for the patient. So that's why we also need to detect the presence of impetigo. The treatment for impetigo is very simple. It's topical antibiotic. Once again, fairly widely available, and the prevalence is the entire population, even though children can be more often affected. So we wanted to have a data set that features several information. So of course, images. So here are images from the actual data set, but also we wanted to have additional information that could be relevant for the dermatologist to provide a teledermatology diagnosis to enable the eye-driven system to use the same information. So in addition to the images, we have quite often actually, so we have a case-based data set with several images per case usually. We have the country of origin of the data, the gender, age, body localization, the presence of impetigo, and the condition. Please also note that the age is not necessarily the exact age, as it can be changed for anonymization reason. The data collection happened in 4 countries and resulted in 1,600 cases and about 4,900 images. Collection was performed in Guinea, Madagascar, Malawi, and Tanzania. This enabled us to have a widespread in Sub-Saharan Africa and collect various types of skin types. We use a dedicated collection platform that is basically a medical CRF with this different question that we ask, that all question that the dermatologists we work with said that are useful for them. However, we are not releasing all of the data since most of the data was not filled by the dermatologist. So we're working with them at the moment to try to be able to release this data as well. And that's how they used to tell us where the body localization is they have a graphical interface where they can click on the body localization. The demography of the dataset is the following. As you can see, we have a focus on pediatric condition. That was one of the goals of the project, and we try to have a minimum of gap between genders. As you can see, we have almost succeeded. Still, we lack female cases between 5 and 13. We are not exactly aware about why this happens. That's also something we want to tackle for future projects, but it is how it is at the moment. Now, regarding skin pediatric fit type, as I discussed, that's a very important point for the project. And here you can see the repartition per country, and you can also better understand why do we use different centers to collect the images, because skin types are not distributed the same in all of the countries, obviously. Typically, Guinea has a lot of cases that are much more pigmented, and Madagascar, because of its location, has a lot of cases that are less pigmented. Now for the dataset, we used a dedicated data cleaning strategy that has been showcased last year at NeurIPS. It's called self-clean, and basically we use representation learning. So we train a model using the Dino method to have a representation learning of our own dataset, and then we perform off-topic sample detection, near duplicates detection, label error detection, and this was supervised by a domain expert. For the off-topic sample, we use agglomerative clustering. For the near duplicates, we use pairwise distance between samples in the latent space. And for the label error, we compare nearest neighbors from the same and different classes. All of this information provided us a ranked list of images, and then human expert is assessing all of these images to establish a ranked threshold. We had 3 dermatologists for labeling for the label error and 3 specialists for the off-topic samples and the near duplicates. And you have to label the images until during 50 times in a row you agree with the ranking. Regarding anonymization, we ensure that the images were correctly anonymized by either cropping or doing inpainting. Let's say, for example, you have jewels. In that case, we were mostly doing inpainting. We had 5 reviewers that did each of them 3 passes on the dataset until they don't find basically anything that they want to remove, and it approximately took 40 hours of work. We also conduct bias assessment. for that, we trained an AI model that was ResNet 50 on the different classes and the impetigo detection. And we wanted to check the result of the model in respect to the gender and the skin types based on the Fitzpatrick skin types. As you can see, results are fairly homogeneous, which is something that is very important for us and for the project. Now, regarding the best results we have, we are constantly monitoring the models released on dermatology, and the current best model on our dataset that we've been able to fine-tune is based out of the Monet model. And as you can see, typically for impetigo, we have extremely good results. And now we are also working to improve the result on the classification detection. Regarding the dataset is publicly available. So you can check the web page at patientderm.github.io or take a picture of this QR code. However, there are a few limitations in regard to the license. First, it's non-commercial use only. We only allow use for research. If you're a company and you want to access the dataset, it's possible to discuss with us, but that's not exactly why the dataset has been released first. Also, there's attribution required, which I think is very common. You must not attempt to re-identify the patient, and there are sharing restrictions to not share direct link to the dataset. Only share the official website links and do not repost the dataset on other platform. Why are we being such restrictive? As I said, the dataset is a pediatric dataset. We have a lot of conditions that affect children, sometimes in body area that are very sensitive. So therefore, we are having some kind of a gate. To access the dataset, you have to fill a small form to explain what is your project and why you want to use the dataset. And that's why we don't want it to be reposted or links directly shared. We want to keep track of who is using the dataset and for what. Finally, what are the next steps for the AI assisting tool? First, we are currently building an image quality assessments for the teledermatology app, and also using self-clean to rank images to know if they are relevant for our training set, because one of the key factors that we observe in other models is that if the data is too far away from the training set, you still make prediction, but this prediction are meaningless. So we want to ensure that our training, the inference, the data at inference is similar to the training data to be able to provide something that is relevant as an output. And we also are currently working on model using the Monet model to not only provide some kind of predicted diagnosis, but also the list of the efflorescences and a ranked images based out of an image atlas that is coming from the dataset. As I said, the project has been funded by Fondation Botnar, so I obviously want to thank them a lot, and all the different universities that has been involved in the project, especially the Hochschule Luzern, the LATIC in Madagascar, the RDTC Training Center in Moshi, Tanzania, the Kahuzu University in Malawi, and the Moelcho in Guinea. And now if you have questions, please feel free to ask.
Thank you so much, Philippe, for the presentation. Yes, so I think you guys have at the bottom a section for question and answers. Please submit any other questions that you might have, and then we will go to them and answer. So I have one question, Philippe, regarding the project. How I do understand that in these countries, some of them don't have the same resources as we have in Europe or in America. How was the strategy in order to acquire those images or to send the images when in places where maybe there is no electricity or probably there is a lack of internet or connectivity.
Yeah, so we had to use a hybrid approach. So we have a website to collect the images, but as you mentioned, you need an electricity access during the upload and an internet access. That might not be the case for in the remote area. So what happened is dermatologists, they went into remote location, for example, in the countrysides, with, of course, patient consent. They collected the data locally on their smartphones or on laptops. And then when they went back to a place where they had this internet connection, they uploaded the data with all of the other information. So they just took notes about the patient, and then they used the websites later on. At some point, we wanted to build a smartphone app, but and to have like a store and forward directly embedded into the smartphone app. But actually, some centers, we could have a lot of issue basically due to the age of the smartphones with the Android version, for example. So we decided in the end to just have the dermatologist taking notes and uploading when they had the internet access. We also paid for the internet access for the centers and provided smartphone and laptops if needed.
That's nice. Is there any intention to collect more images for in other countries in Africa or in other part of the world?
Yes, indeed. But also, apart from collection of pure collection of images, we want to leverage on existing data sets that are currently private. And so we are at the moment pushing for some federated learning initiative that hopefully, if you're interested, guys, you will hear about it soon, hopefully, to try to have both training but also testing sets for existing algorithms. For example, WHO recently released a skin NTDs app. So NTDs is for neglected tropical disease. Scabies is a neglected tropical disease. And they are using this app that is AI-based to detect those cases. So we want to be able also to benchmark a bit more globally these algorithms.
Nice. Thank you so much. We have a question from Sajan. Thank you for your very interesting talk. This project tackled a really important need regarding the data collected. Are they mainly around certain body sites for certain condition, example, finger web spaces for scabies, or is there more of an even distribution? Philippe, you're muted.
Yeah, so thanks for the question. And that's actually something that is very important. It really depends on the condition. So if you look at fungal, for example, you have a type of fungal that is called Tinea capitis that happens on the scalp. And most of the images we have that are based out of the scalp are from fungal infection. Regarding scabies, it's basically the entire body. But for fungal, typically, we have some body localization that are really specific, and that can be a bias for some model that could learn the body localization instead of the actual condition. And so that's also why for us it would be very important to collect more cases and probably also to include in the other class healthy data of healthy scalp. And that's also something we're working at the moment to either collecting actual data or to use some generative model. That is also an aspect that needs to be addressed for these conditions that also have a very specific body localization.
I hope the question was answered. As I mentioned, guys, at the bottom you have a section for questions. Feel free to ask any question to Philippe on the project. It's very interesting. Philippe, do you have the a link to the dataset that can be shared and we can check it and try to download the data, or how do we have access to this data?
Yeah, so as I said, so you just go to patient .github.io. I can share again the link if you want. Yeah, so I can share the link again. For example, here. Sorry. Yeah. So here you have the link, passionderm.github.io. You can scan the QR code too. And yes, so you will get a form. You can get access to a form through the website. And this form, you just have to basically say who you are, an email address, what is the goal of the project, what would be your research approach, and then we will reply. So I'm doing most of the replies, so please be a bit, I mean, usually it's a week, up to a week to reply, because we have several applications and also other projects running. But yeah, so then you will get an access to the website through GitHub actually. And also we might have to ask you a few more questions if we have some doubts about, or like open question based on what you've written, but usually it's really fast. And then we reply also much more quickly for that. So that's the whole process.
Nice. We'll give a that's website. Nice. We'll save it. I will give a couple of more minutes. If no one has questions, then we can leave for the early weekend. I think we don't have any more questions. So I will thank you, Philippe, for the session of today. It was a very interesting talk. I hope that the people here contacted you for access to the data and see more contributions with this data set. And thank you so much for the talk.
Yeah, you're welcome. Thank you very much for the invitation. And yeah, if you want to contact us, please feel free to do so through the website. That would be the easiest way.
Perfect. So thank you so much, guys. I wish you a pleasant weekend. Have a nice day. See you all.